Okay, so far we talked about what happens if you don't have any forces, right? So now the question is, what happens if you do have some external force? What will happen, right? So as we learned, it's not intuitive at all, right? You think that forces is what causes motion, but Newton's first law, as we learned, or Galileo discovered that force is not what causes motion. If things move, they stay moving. This is what happens, right? You don't need a force to keep things moving. If it's initially at rest, it'll stay at rest. If it's initially moving, it'll keep moving with the same speed and direction, i.e. same velocity. But what you need is a force to slow it down. But how does it slow it down, right? And that is what Newton's second law will tell us. So Newton's second law tells us that it will change the velocity, right? And that's what we call acceleration, okay? So let's write that down. So this is Newton's second law of motion. Okay. So what he says is that if there is a net external force, objects will accelerate in proportional to that force. If there is a net external force, right? Understand what that means, right? Net means that if both sides cancel out each other with the same force, then there's no net force. But one side has to be larger than the other to have a net force. External means it has to be outside of this. It has to come from outside of the system. But yeah, if you have a net external force, the object or the system of objects, it could be, right? The object will accelerate proportionally to the force. Okay. All right. So what does that mean? The key word over here I need to explain is proportional. All right, and acceleration as well. All right. So let's start with acceleration. Acceleration means the change in velocity. Okay. In fact, let's write it over here. So acceleration is defined as the rate of change of velocity. Okay. It's how fast the velocity will change in how much seconds. So in other words, I can also write it in. It's the change in velocity over the change in time, right? What does that mean? This little triangle means that the triangle translates to change in, right? It's the notation, mathematical notation of change in. Right? Just a lazy way to write that. I could have written change in velocity over change in time, but I could do that. So as an example, right? If your car moves from 50 miles per hour to 60 miles per hour, what's the change? Well, it's 10. So it's 60 minus 50, right? That's the change. And how long does it take? Well, let's say it took you 1 hour to do it, right? So what was the unit over here? It was miles per hour. Okay, so the change of that, so the acceleration is 10 miles per hour. Okay, notice the unit is a little bit funny. It's distance per time. If I use SI units, which is meters, kilograms and second, it's a little bit more obvious. But in general, the idea is the final velocity minus the initial velocity over the amount of time taken. So you can also think of that as the final time in your clock and the initial time of your clock. So if you start your stopwatch at 0 seconds and your final time, if it takes you, let's say 10 seconds, so you do 10 minus 0. And what's the velocity change? Let's say you're running, so this is a second example. Let's say initially, let's say you're running at 1 meter per second. And finally, you start to speed up, right? So you end up with 21 meter per second, like that. So your acceleration will be, well, 20 divided by 10. Let's not worry about, so this is in seconds as well, but let's not worry about the units. Let's do the math first. So 20 minus 1, so that's 20, 10, so that's 2 meters per second, like this. or sometimes we write that as 2 meters per second square. Okay, so that's how you get the units, but that's also how you get the value. Okay, all right, so that's what acceleration is. Essentially, we'll get to more of the math in a second. I want to go through the concept first, is whether velocity changes. Okay, now what is proportionality? So just remind you, so hopefully you remember that. But if I have two quantities, if let's say if A is proportional to B, okay. Now remember I said mathematicians are lazy animals, so we invent symbols for everything. Even that looks like a lot of words, especially such a long word to write. So we invent a symbol like this. Okay, so it's almost like an infinity sign with a gap over here and a little bit more squashed. Okay, a little bit like, yeah. So this little symbol just means A is proportional to B, right? It's a lazy way to write that. And for taking notes, it's very good. When something is proportional to something, that actually means, okay, that implies that A equals to a constant times B. So every time you see this or this, you can replace it with this. That's what it means. If two things are proportional to each other, all right? And this is a constant, which means no matter what A is or what B is, this will stay as the same number. And it's called the constant of proportionality. Okay. So what does that mean? That means that if something is proportional to something, even before you look at the formula, what that really means is if B is if you increase B by a certain amount of time, a certain amount of factor, A will increase by the same amount of factor. So if I double B, A will double. If I triple B, A will triple. If I quadruple B, A will quadruple. All right, it was increased by the same amount of factor. All right, so let's see if that makes sense with the formula. Right, so if I increase B, right, so what that means is let's say if B is 1, right, then what is A? So A is K times 1, right? So it's K, right? Whatever K is, it's going to be some number that never changes. If B is 2, well, A will be K times 2, then it will be 2K, right? So this was the old B. If B is 1, now I doubled B, right? What happens to A? Well, A was K, and now it's 2K. Right? So that makes sense if I can just massage this in, right? So if I multiply B by 5, then I'll need to multiply A by 5 for this equation to be correct, right? Another way to think about this is, maybe I'll write it separately, is let B prime, so I'll invent a new B, right? The new B, I could write it as B new, right? Is 5 times of the old B. Okay. Well, what happens? Well, the A new will equals to K times, well, B new. That's 5 times of B old. Okay. So what can we do? Well, K times 5 times that. Well, I could write it 5 times K times B old. But remember, K times B old, if I put old over here like this, my K times B old is A old. So I have 5 times the old A, like this. So you see that if B new is 5 times of the old B, then the new A would be 5 times of the old A. All right. So in math, we try to also be lazy and not write so many words. So what we can do is, it is very common. You'll see that in math and physics, we put a prime on the new variable. Okay. So this is the new B, and this is new A. Well, according to the formula, right? So then A is always proportional to B. So the new A should be proportional to the new B, and the new B is equals to 5 times the old one, which does not have a prime. The old one does not have a prime. But now we see that K times B is 5. K times B is the old A without the prime. So you see that the new A is 5 times of the old A, when the new B is 5 times of the old B. All right, so that's just a quick reminder, or hopefully a different perspective if you haven't thought about it this way before, of what proportionality means. Okay, all right, so let's go back over here. What Newton's second law says is that it says if there is a force, let's call that F, the object will accelerate proportional to the force. So it means that the acceleration is going to be proportional to the force, okay? Which means, as we just recapped, you can rewrite this as F equals to a constant times A, okay? Anytime when something is proportional to something, you can write it as some constant times A. And that constant is what we call mass, okay? So I'm going to actually replace that with the symbol m. So you may or may not have seen this before, one of the most famous formula. Basically, I can summarize Newton's second law in writing this. When just a tip in exams, if you're asked what is Newton's second law, you can either write it in full English like this, or you can write it in symbols like this. But if you write in symbols, make sure you define your symbols, okay? Define your variables whenever you write something in variables. So I'll do that over here. So in an exam, you'll write this is the force on the object. This will be the acceleration of the object. And this constant proportionality is what we call mass. Okay. All right, so that's Newton's second law. Let me summarize what that means is, with the first law, we learned that if you don't apply a force on something, it will either stay at rest or it will continue moving at a constant speed. But now if you do apply a force, right, if you have no force, that's what's happened. If you do have a force, it will, so if you do have a force, it will accelerate it. In some sense, you'll sometimes hear people say Newton's first law is just a special case of Newton's second law, because if F is 0, that means A is 0 as well. And that means things do not accelerate, right? So in some sense, make a note of this. Newton's second law, sorry, Newton's first law is a special case of Newton's second law. If that is not clear, we'll see, right? So because Newton's first law says if F equals to 0, right? Now Newton's second law says that if F equals to 0, then as you can see, then A must be 0, assuming the mass is not 0, like if something has a mass. Then if A is 0, that means the velocity doesn't change. Right? Because acceleration is the change, it's how fast the rate or how fast the velocity changes. So if the velocity doesn't change, that just means it's constant velocity. Okay. So as you can see, I can almost derive or deduce Newton's first law out of Newton's second law. Okay. All right. We'll see where this takes us next, because now that we have done two things, we learned what a force is, and we've learned what does the force do to the objects. We will move on next to look at what are the types of forces and how to find all the forces on an object. So we'll learn that in the next video.